This is GATE 2017 set 2 electrical question number 31. The output yt of the following system is to be sampled so as to reconstruct it from its samples uniquely. The required minimum sampling rate is being asked, where x omega, that is capital X omega, is the Fourier transform of small x of t, which is in time domain, then multiplied with cos 100 pi t, that forms this signal, which is given as the input to the system, having impulse response ht equal to sine 1500 pi t by pi t, and output is yt. Now for yt, it is to be sampled so as to reconstruct from its samples uniquely. Then the required minimum sampling rate is being asked for yt, for sampling yt. Now for NPTEL reference, you can refer to lecture Sampling Spectrum of Sampled Signal, Nyquist Criterion of the NPTEL course Principles of Signals and Systems by Professor Aditya K. Jagannatham, Department of Electrical Engineering, IIT Kanpur. For its full data, you need to know the Fourier transform of sinc functions, which is sin 80 by pi t. The Fourier transform of sin 80 by pi t is 1 for the bandwidth less than equal to a and 0 elsewhere. So if you transform this time domain signal, it will become like this, a rectangular pulse with bandwidth of omega between a minus a to plus a, which will be 1, elsewhere it will be 0. So that will form a rectangular type of signal in the Fourier domain. Convolution of two time domain signals. When the Fourier transform of two time domain, the Fourier transform of the convolution of two time domain signals is the product of their Fourier transform, and the product in time domain results to the convolution of their Fourier transforms with a factor 1 by 2 pi. If xt's Fourier transform is capital X omega, then capital X of t, that Fourier transform is 2 pi x small x of minus omega. This is a property which is the duality. Now this is an important property, where if you convolute with delta having a shift, that is delta t minus beta, then xt when convoluted with this delta t minus beta, the resultant time domain signal is x of t minus beta. It is seen that convoluting with a delta signal, the shift is appearing in this time domain signal. Other every properties of this time domain signal remains same. Now if this parameter inside is t or omega, nothing matters, because these are all independent variables and property remains the same for both time domain and frequency domain convolution with respect to delta. The Fourier transform of cos of omega t is pi into delta omega minus omega 0 plus delta omega plus omega 0, and if same is done with product term, then xt into delta t minus t0, we get x of t0 into delta t minus t0. Also we need to know that in order to properly reconstruct the signal of x of t having maximum frequency fm, then or in other words, x of omega having maximum bandwidth fm, then it should be sampled at least at a sampling frequency at least greater than equal to 2 times the maximum frequency. This is the Nyquist criteria, and the rate is Nyquist rate, which is fs equal to 2 times fm. Nyquist criteria. Coming to the solution, xt is given in Fourier transform form, where x omega is having a response like this. When this signal is multiplied with cos 100 pi t, it forms x1 of t, which is given as input to this system, having impulse response h of t equal to sine 1500 pi t by pi t. to form yt. Now yt we need to find, which is nothing but convolution of x1t with ht. x1t is nothing but xt into cos 1000 pi t convolution with ht. Now if we take Fourier transform, we get y of omega equal to, this is x1 of omega, and since there is a convolution in time domain, by this property we see convolution Fourier transform is product, so into h of omega. However, these two are time domain signals, so their product in Fourier transform will become the convolution with a factor 1 by 2 pi x of omega convolution, the Fourier transform of cos of 1000 pi t is pi times delta omega minus omega naught, which is 1000 pi plus delta omega plus 1000 pi so this times h of omega. This pi can be deducted with this and we are remained with half. Now any convolution with delta results in a shift, so it is becoming x omega minus 1000 pi plus x omega plus 1000 pi multiplied by h of omega. So now we see y of omega is x of omega minus 1000 pi plus x of omega plus 1000 pi into half into h of omega. Now x of omega is already given in the question, so x omega minus 1000 pi and x omega plus 1000 pi, these two when added together and divided by 2 will depict a signal, because these are shifted, so 0 to 2000 pi minus 2000 pi and this will come at minus 1000 pi 1000 pi. So this will somewhat depict the nature of y of omega divided by h of omega. Now this signal multiplied by h of omega, so sin at by pi t is nothing but, this is h of omega, it will be a rectangular structure having bandwidth minus 1500 pi to plus 1500 pi, and this will be 1. So when we multiply these two, resultant will be y omega, which is, so beyond minus 1500 pi, we superimposing this, nothing will be there because this is 0, so this will also become 0 when multiplied. So we are getting a function that is, this side it will be 0, this side it will be 0, so minus 1500 pi to plus 1500 pi, it will be 0 beyond that, and here it will follow this curve. So this is minus 1000 pi and then it will be like this, again plus 1000 pi and it will be like this. From here we can depict maximum frequency of signal is this much, 1500 pi. So minimum sampling rate equal to 2 times frequency of the signal, that is in radians, divided by 2 pi in hertz. So this is 1500 hertz. This should be the minimum sampling frequency of this signal for proper reconstruction. So 1500 samples per second, which is hertz, is the correct answer. Option B is correct. Thank you.